Good morning, everyone. My name is SangKi, convener of Working Group 10 of ISO TC211. And I'll be presenting the standard development for Korean National Digital Twin. Probably most of you know, but there are other foreign experts who do not know the Korean NGIS master plan that started in 1995. So it's been quite long years that we have been trying to establish national spatial data infrastructure, and it's evolving. So now from 2023, we start now 7th NSDI master plan. And seventh NSDI plan focuses on integrating all relevant information through geospatial foundation, thereby realizing national twins at all levels. Korean government has this Korean National Digital Twin Strategy. It is part of the Korean New Deal 2.0 Digital Super Innovation Project, and includes a using spatial information linkage for national digital twins. So the strategy has 4 components of it. One is to establish the foundation for industry growth for digital twins. And second one would be the creation of large-scale leading market and enhancement of technological competitiveness, mainly focused on research and development, and finally standardization and system improvement. So as standard people, we are very interested in the 4th component of it, and thereby we developed the concept of national digital twin. I know that the UK and Australia and New Zealand has the similar concepts. But as we look at the national digital twin, this is the digital twin of national land. And we have all these data collection devices collecting sensors through sensors. And then we realize the digital national land with 3D information, and that would be used for simulation and control and management of information. Why National Digital Twin Standard? Obviously, a lot of agencies, governments, local, central, and public agencies, and private sector are starting to develop their own digital twins. So we are looking at a multitude of digital twins. But digital twins has to fit together to be useful. Their digital twin might be used in one part of the country or part of an urban area, but we need to have the whole picture of a national digital twins. These twins has to be federated, I think, and so we have a federated digital twins, but still for federation, we would have to have a solid foundation to fit them all together. And that is the part that the geospatial standards are coming in. So we have this conceptual framework for national digital twin standards. So this is not the digital twin itself, but the standards framework. And we have a reference framework at the conceptual level, and we have a conceptual standard for that level. Then mostly we are focusing on developing data standard. So for data, we have a data product specifications for national digital twins and core data models. And these data product specifications and data models will be used for quality control and metadata implementation. And application side can use all these data developed by, compliant to these national standard to fit them together and use. For reference framework, we have this diagram. This is quite complex, but basically at the bottom there's a device control and data acquisition layer. Then we develop digital twin data, which will be used for data management and data processing and services. And I would not explain every part of it, but this is the reference framework. This is the important part. We have this data model structure for digital twins. This has a three-tier structure. The top and middle tier models are national standards. So we have a reference model standard and then core model standards. And then the bottom tier would be the domain-specific application and the domain models. But we like to have these domain models based on the core model in the middle layer, so that they could extend the existing core models to develop their own domain-specific data models. Then we could actually realize some interoperability among domains. So this is the standard development strategy. This process starts by analyzing use cases and requirements for each domain. For example, buildings, underground facilities, transportation, and so on. Then these requirements are checked to make sure that the consistency across standards are maintained. Then the national standards are developed by profiling the appropriate international standard. So here you're looking at the standards in action, that the ISO standards and OGC standard and all these standards are being actively used to implement or create a national standard. So this process analyze the requirements, then the data model, data quality, metadata, and data product specification are developed at the same time to make sure that there's no inconsistency among these standards. Then we take ISO and OGC standard to base our national standard and extends it or to profile it and to make the national standard. Here's the tricky question. When we try to work on some domains, it is not very clear which standard should cover this particular domain. For example, if you look at the transportation, there are some buildings, for example, you have an underground part of the buildings. There's an indoor inside the buildings. Transportation is the same. Tunnels are completely under the surface, but bridges are over the surface and things like that. There are different, so we have two different views. If you look at from the land view, then there are buildings underground and bridges and tunnels, and we would classify them into these different domains, but still inside the object, there's a room inside the building, there's a room in the tunnels actually, and bridges, and there are hollow spaces as well. So how do we do that? So basically what I'm saying is that mostly these objects are handled by the particular domains, but still there are some challenges to fit them all together. So we looked at it, buildings, indoor space, terrain, transportation, and underground spaces have the concept of space in common. If you look at the CityGML core module, then you know that the space concept is very basic in fitting all things together. So we actually borrowed that concept. So space is the connecting component, a concept to fit everything together and to eliminate redundancy and overlap between standards. So I just mentioned the indoor, building, underground, and transportation spaces, and they all use the same space concept. So this isn't just an example of modeling these relationships. We have a tunnel, and we have a terrain. Tunnel is completely below the terrain, and we need to model the relationship between tunnel and terrain. And then inside the tunnel, there's a hollow space, which will be covered by the indoor model. So when we deal with indoor data model standard, and it not only covers the rooms inside the building, but it also covers the space inside the tunnel as well. Core models are based on most of the core models are based on SiA 3.0. We have a Scott here, who's really, he should be very proud. We have SiA 3.0 as the base, and we actually developed all these core models, profiling or extending SiA 3.0. There is a significant change between 2.0 and 3.0, and we try to take as many functionalities of SiA 3.0 as possible. And this is a profiling example. We have a transportation data model, and SiA 3.0 has a different concept of a level of detail. Then the indoor features can be described at the level 0, level 1, level 2, level 3. So if we extend it to the transportation on the network, linear features, and the aerial features, then there are a whole different, for example, LOD0, we can extend it to LOD 0.0 through LOD 0.3, which will describe each lane of a highway. So that is one of the profiling example of the transportation data model. Indoor data model standard also based on SiA 3.0, but indoor, as I mentioned, is it overlaps in many areas. Construction module in the core, and we also have a indoor GML 1.1 and those has to be considered as well. So we have an anchor node extension for that. So this is basically how the indoor package has been constructed. This is one of the examples of the National Digital Twin building data. It has all these schemas and covers 2D and 3D data very, very efficiently. And this will be explained further in another presentation in this session. So I'll just show some of the outcome of the building model. And obviously, not only LX, but a lot of local government, for example, Seoul Metropolitan Government, builds digital twins and use them in various applications. This is one on the left is a fire simulation done on LX's digital twin project, and right-hand side is a river monitoring applications. And you will have a chance to look at actually running these applications at the end of this seminar, I think. So I'm just giving you the snapshot of it. And finally, this is the roadmap that we are using. 2 years ago, we started building the reference model standard and some standards on building. Then we expanded it to transportation, indoor, underground, and terrain, and also started verifying that the standards are actually correct and working. And so test and verification are being done. And this year, we are putting them into the national standard. It takes some some time to get it into the Korean standard, KS, national standard, and still we also do the test and verification. Then we have management issues. How do we manage these models? And so we have a model registry design and development research. And we will start using these modules as soon as the standards are being passed. And then obviously there are a lot of R&D needs to be done for example, dynamic data handling and sensor data handling and simulation support, service support. These will be all done in the coming years. But I think it's a pretty meaningful start for developing a national digital twin standard. And I think that is the last slide for me. Thank you for your attention.